Hey, hello. Extremely sorry, friends. I'm not sure why this has happened and when this has happened. Uh, Hello. I'm not sure why this has happened. Are you all able to hear me? Let me ask this question.
I can hear you, but
You can.
yes, the audio is clear.
Okay. Are you all able to hear me? I don't know. Okay. I just published this. Can you all please respond to the poll question? Wonderful. Wonderful. Let's give quick 2 minutes time for everyone to join in. I'm not sure when this has happened. Um, Let us see. Yep, we will have to ensure. Oh, it's 4 minutes, is it? Okay, so let us see. Um, what has gone wrong? We would wait for quick 2 minutes because there are a few people who might have who might be joining in. So we will see. Usually that doesn't happen. Let's see. Okay, so we should be able to start in the next 2 minutes. Yep, yep. Vehicle breakdown, is it? Okay, vehicle breakdown. So that is the survival analytics stuff, right? All right. So sorry, friends. So here, as part of this vehicle breakdown, I was saying that what we have used industrial IoT sensors, cloud computing, and artificial intelligence, a combination of those, which is the perfect combination even today, right? Wherein you combine the strengths of IoT, cloud, and AI, industrial IoT sensors, plus the strength of cloud computing, okay, and you also combine it with artificial intelligence. And then you build amazing, you know, solutions when you can combine the strength of all these things. Then I was saying that if you go to 360 digit MG, let me go back and show you that. Here you will see something called as mind map. If you click on this mind map, you will have a lot of mind maps when you do a drop down. The area of interest for us would be AI and deep learning. When you click on AI and deep learning, you get here, click on that. Okay. And here you will get a high level overview of entire artificial intelligence and deep learning. The reason why we have named this as practical AI is because we have this project management methodology called CRISP-DM. CRISP-DM stands for Cross Industry Standard Process for Data Mining. As part of this, there are 6 stages. Stage 1 is understanding the business problem. Stage 2 is collecting the data based on the business problem. Stage 3 is cleansing the data. Stage 4 is data mining or machine learning. Stage 5 is model evaluation, and stage 6 is model deployment. Let me give you a basic example on how to understand the business problem and how to proceed further. Okay. I keep giving this example of a bank because it is very easy to understand. Okay. And then I will also give you example of agriculture. Let me give you an example of bank. Okay. Here, say, uh, loan department head walks up to you and says that, my dear artificial intelligence experts, I have a problem to be solved. Then you check on what that problem is. And the loan department head would say that, do you know what? Significant proportion of customers who take the loan are defaulting on the loan. Significant proportion of customers are defaulting on loan. If significant proportion of customers are defaulting on the loan, then how would you help this particular bank resolve this issue? Okay. Even before you proceed further, once you have the business problem, the first step is to understand the business objective on what you want to achieve. And also you need to lay down the business constraint. Business objective and business constraint. Business objective here is, since significant proportion of customers are defaulting on the loan, you might want to minimize the number of defaulters. So you'll say, okay, let me minimize the loan defaulters. So what would you do? You will build an application, say, wherein you'll have the database with all the details of all the customers who have applied for the loan, right? All the customers who have applied for the loan until now. And whenever there is a new customer who applies for the loan, you capture the details such as age, education, gender, all those details. And using this data, say you will use Python or you will use R, and then you're going to build a predictive model. A predictive model, which will then predict on whether a person will default on the loan or not default on the loan. Whether a specific customer who applied for the loan, will that person default or not? If this customer says that, or if the model predicts that for this customer, there is 90% probability that the customer might default on the loan, then my question to you all is, would you approve the loan or would you reject the loan? What would you do? Let me put this as a poll question. Poll question coming your way on what would you do. Let me see. Poll question here. I'm going to put a new poll. Will you approve or reject the loan? Let me see how many of y'all will be rational at thinking and then responding. Do not worry, we will not track this, so you might want to try out. we'll not track on how many correct, wrong, who is answering, nothing. Okay, you're free to answer this. Yep. So for this question on, would you approve the loan or reject the loan? Can you let me know on what would you do? If the prediction says that there is 90% probability that a person might default on the loan, then what might you do? Would you approve the loan or would you reject the loan? That's the question here. Okay, you would either approve or reject the loan. Yeah. So let me look at the response. Okay, 56% of y'all are saying yes. 50, another percentage, certain percentage of people are saying no, we would not. If there is 90% chance that someone will default on the loan, that means they will take the loan and do not pay back. Then why do you even want to have such a person, right? Why do you want to even approve the loan for such a person? So most often than not, you would reject the loan. But if you, even before I get there, okay, how do you think banks become profitable? What do banks do? They lend loan. And if you lend loan, you in the sense banks will get interest rate or interest amount, rather, not rate, interest amount. If they get interest amount, based on that amount, they make profits. And if you're rejecting the loan, then the banks are not even given an option to lend the loan. So obviously their profits will decline. Hence, your client will also put a constraint on you saying that while you minimize the loan defaulters, try to also maximize the profits. Now, the moment there is business constraint, the moment you have a business constraint laid down, it will be an interesting problem to solve. Now it is interesting. If it is only to minimize the defaulters by hook or crook, you can do that. The moment business constraint is levied on you, it becomes a challenging problem to solve. Right? So what we have done is, this is a project that we have done, and because of this, we featured in CIO Review magazine, and our company InnoDataTex was rated as one of the top 20 data analytics solution providers. Okay, so what we have done there, that's an interesting bit, right? So let's understand that. So what we have done is, we have implemented something called as survival analytics. What is survival analytics? Alongside predicting on whether a person will default on the loan or not, we also predicted on after how many installments will a person default. Person will default with 90% probability, but then after how many installments? And say the prediction says that this person will default after 28 every month installments, after 28 months of installments. That means you can still approve the loan. You can still approve the loan, but then you have to reduce the loan tenure to 24 months. Approve the loan. You know that after 28 months, this person will default. So you know for a fact that until maybe 24 months or so, it's safe zone. You can approve the loan, reduce the loan tenure to 24 months, reduce the loan amount to be disbursed, increase the interest rate maybe if you want to. But this way, you are both minimizing the defaulters as well as maximizing the profits at the same time. And this is the kind of solution that you need to provide to the customer. And only then people will value you. If you just minimize defaulters by saying, okay, there is 90% probability that someone will default, so reject the loan. You cannot go like that. You need to abide by the business constraints always. The next thing is data collection. Once you understand the business problem, you actually record your objectives and constraints. Typically, your objectives and constraints should be for 2 to 3 words. And you need to use data optimization terms to the extent possible. That is, you use minimize, maximize, etc. And then you'll have a project charter. Project charter is the first document which gets created on any project. It's going to officially say that, hey, here is a project and it's approved by the sponsor and you can proceed further. Once this is clear, you proceed further with data collection. As part of data collection, you have data types. We are going to discuss in detail about all these data types. Because once you understand the data types, you'll be good to proceed further. Okay, and then we'll understand a little bit of data cleansing and we will get into the deep learning algorithms. So first things first, you need to understand the difference between continuous data and discrete data. Continuous data is that data which, if represented in decimal format, okay, if you represent the data in decimal format, it makes sense. For example, weight of a person. I can say that, you know what, I weigh 75 kgs. You'll say, all right. If I say my weight is 75.1 kgs, you'll say, okay. If my weight is 75.1231 kgs, you'll say, all right, this guy is being very accurate. It still makes sense. Though I'm representing the data in decimal format, it is still making sense. So this is continuous data. On another side, you have discrete data. Discrete data is that data, if you represent that in decimal format, it does not make sense. For example, I can either say I have one house, or I would say I have one car, or I have two cars. What if I say I have 1.789 cars? You'll say, oh my God, this guy is a mad person. How can you have 1.789 cars? You either have one car or two cars or 10 cars, right? The moment you represent this in decimal format, it will stop making sense. And this is discrete data. A few questions for y'all coming your way on the poll. Can you all please respond to it? The poll question is here. Height of a person, is it continuous or discrete? Yep. Please, can you all respond to this? Please, can you respond? Poll questions, all we know is how many people responded. We don't even know who has responded. So don't worry about tracking your accuracies. So you just go ahead. 70% of you all approximately are saying that it's continuous data. Absolutely, my dear friends, it's continuous because height can be represented in decimal format. If you're representing height in centimeters, you can say 163.72 centimeters, 168.01 centimeters. It can be represented in decimal format also, and it actually makes sense. If you represent something in decimal format and if it makes sense, that is called as continuous data. Let me ask you another question. Okay. This time I'll be a little funny. Okay. Number of marriages you have done. Is this continuous or discrete? Yeah. What do you think? Number of marriages. Can you represent that in decimal format and does it make sense? No. But I'm really happy that at least 85% of y'all are, getting it right. Absolutely, my dear friends. Either you marry once or twice or thrice. Can you marry 1.786 times? You cannot. The moment you say this, your wife is going to beat you, right? And number of times your wife beats is also discrete data. Unfortunately, yeah. One time, two times, three times in that way. Okay. That jovial bit aside, you know what? We have count data, we have categorical within discrete. Categorical, let me quickly explain. Do you know what? We have worked on a project wherein there was this semiconductor manufacturing plant, which was manufacturing the circuit of your mobile phone, and circuits of laptops, so on and so forth. So what we have done is we have placed a high-end camera on this. Okay, and the moment a circuit goes through it, it will quickly capture the image and it is going to classify on whether this circuit is defective or not defective. Okay, whether it is defective or not defective. Defective or not defective classifying in this way is called as binary. It is binary categorical data. And we also have multiple categorical data. For example, is this particular image, the same example that I've given. For example, um, if I go here and click on sample images, it would come up. We had to classify on whether an image was benign calcification, dense malignant calcification, dense normal, dense suspicious. There are multiple categories. It's not just classifying on whether your image is cancerous or not, benign or malignant. It is all about classifying all these 10 classes. Forget about contour masking, but then barring that, you have fatty, benign calcification, etc. So having more than two classifications would classify to fall under multiple categorical data. And I think this is good enough. Categorical, count, continuous. Let's not get into interval, ratio, and nominal and ordinal. Okay, that's part of our typical data science training. And you have qualitative data versus quantitative data. Simply put, your quantitative means numbers. This I often hear this example. If employees are late to office, especially in our office, then when we check with them on, hey, why are you late today? They say, do you know what? I stay very far off. It takes a lot of time for me to reach office. Okay. When you make a statement that you stay very far, not far, then this is qualitative data. Qualitative, very far. Now, how do I quantify it? Probably I'll go to the HR and ask the HR person on, hey, how far does Mr. Ravi stays from office? Then HR might check the records and say, do you know what? Mr. Ravi stays 1 kilometer away from office. Oh my God, Ravi, you told you stay very far, but you stay only 1 kilometer away. Ravi will say, yeah, that is what I meant. 1 kilometer is very far for me. So that is, very far means it's qualitative. Quantitative means you quantify it using numbers. If you say that this training is good, then on a scale of 1 to 5, if we can take a rating, and if you say 5, that means you're very happy, right? So you're quantifying, basically, you're giving some number. And continuous data and count data would fall under quantitative. So these two are called as quantitative. Okay, and your qualitative data is categorical data. Okay, so that's the difference between qualitative and quantitative. Now I have a question for you all, poll question coming your way. Please, can you all respond to this? And my question here is, number of vehicles which cross a traffic signal in the morning at 8 a.m. is 268. Did I type something incorrectly? Uh-oh. Okay. Is this qualitative or is this quantitative? Yeah. Can you all go for this? Let me see how many of y'all will get it right. Number of vehicles which cross a traffic signal in the morning at 8 a.m. is 268. Wonderful. Quantitative, because we are quantifying it using number. We are saying 268 vehicles, right? Let me ask another question. And here the question is, number of people who pass the security check every day at 11 a.m. is around 398. Is this qualitative or quantitative? Yep, go for it, please. Is this quantitative or qualitative? Wonderful, it's quantitative, right? Because it's a number, 398. I understand, why the number has actually slightly less in quantitative and slightly more in qualitative, because naturally, after I ask one question in quantitative, you assume that there'll be another question on qualitative, right? That might be the reason for this. Statistics. Okay. And let us discuss about yet another very, very important thing, which is structured versus unstructured data. Structured data is that data which can be placed in a nice tabular format in rows and columns. If you can place your data in a nice rows and columns format in a tabular format, then this is called as structured data. On another side, you have unstructured data. When it comes to unstructured data, you'll have videos, images, audio files, and textual data. All these are unstructured in format because in the raw state, these data types cannot be placed in a tabular format. And do you know what? You can, however, convert your data, which is in unstructured format, and you can make it structured. You can transform your data to make it structured. And how do you do that? How do you transform the data to become structured? I'll let you know. Videos, basically, when you look at any video, I'm sure you all are aware that videos are nothing but collection of images which are taken at a rapid pace. So if you have all these images which are taken at a rapid pace, then it forms video. And these images are called as frames. And this is called as frames per second. If you have more frames per second, more will be the quality of the videos, right? High definition videos, etc. It's simple. I mean, we all would have done this, right? Flipbook. What you all, we all, rather, not you all, we all would have done this. Basically, it's called as flipbook. You flip it in that way. Okay, I can also play this video for you. Come on, ads are a little disturbing. Okay, let's look at that. You're flipping in that way, right? And it appears as if it's a movie. That is exactly what frames of image mean, right? So when you say video analytics, it is nothing but image analytics. You are breaking down the video into multiple frames of images, and each image is taken out. So let me take one frame here, and each of the image is again made up of multiple pixels. Okay, you'll have multiple rows and columns. You take each pixel value, and each pixel value would range between 0 to 255. 0 means black and 255 means white. Okay, black color means 0, white means 255. And do you know what? As part of this program, we are going to extensively work on images. Extensively. Image processing and all that. Okay, that aside. You take each of these pixel values and place it in tabular format. For example, if this is your tabular format, you take the first pixel value, put it here. You take the second pixel value, put it here. You take the third pixel value, take the fourth pixel value, so on and so forth. You put all the pixel values here. Okay, so that's how you transform your unstructured data to structured. When it comes to audio or speech, we use something called as MEL frequency cepstral coefficient. This is one way of converting your unstructured data to structured. And when it comes to text mining, there are many ways: bag of words, term, document matrix, so on and so forth. Yeah, that's very trivial thing. Dealing with videos and images is very, very important, and that is where we will be spending our time. Next, we also have something called as big data versus non-big data. If you were to take a textbook example on big data and understand about big data, then you all just have to say that, okay, do you know what, 3 V's or 4 V's or 5 V's is what big data is made up of. What does that mean? You know what, I'll go with 4 V's, not three, not four, not five. If the data is coming at uh, if data is of huge volume, humongous data coming your way, and if the data is coming to you at a rapid speed, high velocity, and if you have variety of data, that means images, videos, IoT sensors data, log files, so on and so forth, and then if you have a lot of veracity in the data, then it classifies to, I mean, you can categorize that data as big data. This is very bookish. And here we have told that it is practical AI and deep learning, right? So if I were to give you a practical example, then this is what I would say, that any data which you cannot store given your computer or server resources, for example, the maximum hard disk space that you can have on your computers would be 2 terabyte. Now, given the current condition, current world, I mean, it might increase later on. Today, 2 terabytes. And if you look at Pratt and Whitney, which is a company which manufactures the aircraft engine, etc., in 12-hour flight, it produces 844 terabytes of data. If it produces 844 terabytes of data, then how can you store it on your computer? It has only 8 terabytes, and you're speaking about 844 terabytes of data, and that too in a single flight journey. If you have multiple flights, and then just imagine the volume of data, you cannot even handle that, right? So if you cannot store the data, given your limitations, given your data center or given your computer limitations, then that's big data. From storage perspective, you cannot store it, kind of, right? You just ran into big data problem. And another thing that we need to discuss is from processing perspective. What do you mean by processing? If I were to give you, say, 200 MB Excel file, trust me, friends, if you haven't tried it, I request you to try it. 200 MB Excel file, just try to open that, and it will go on and on and on. That circle, you'll see that round circle, you know, as if it's trying to mesmerize you, the round circle. And do you know what? We jokingly used to talk about this, that if you're not in a mood to work as a data scientist or AI expert, all you need to do is pick up the biggest Excel sheet and just double click that. And that's it. You can go have your breakfast, you can have your coffee, you can have your lunch, you can go out for movie, come back in the evening to office. Still, the circle will be going round and round and round, right? Just 200 MB Excel file I'm speaking about. So if your system cannot process something, then you just ran into big data problem. It need not be those 4 V's that I've defined. It is very contextual. And any data which you can store easily and process easily, that's non-big data. So that's the difference between big data versus non-big data. And A few more things which are very important, because do you know what, we become too much of textbook oriented, that we forget the big picture, that whatever people are learning, they need to implement it somewhere, right? So if you have data which is in structured format and big data, you resort to Hadoop. Hadoop is a framework. It is not a database. Hadoop is not a database. Okay. Hadoop is not big data. Hadoop is a framework which is used to handle big data. Okay. And you have Spark, which is used to process the big data. That aside, if you have structured data which is big, you make use of Hadoop framework. If you have unstructured data which is big, still you use Hadoop environment. But then if you have structured data which is non-big, you make use of something called as relational database management system, such as Oracle database, or you have Microsoft SQL, you have MySQL, and you have a bunch of other things. And when you have unstructured data which is non-big, then you store your data in NoSQL. Why do you need to know these things? Because without knowing this, what are you going to train train the people, and how are they going to implement in the real world? So at least you need to give this big picture, which is very important. Once the big picture is clear, then whatever concepts you teach makes sense, because they know that, okay, I'm learning this to actually implement in that way. Okay, next. We have cross-sectional data, time series data, longitudinal data, or panel data. So cross-sectional data, I'll first explain that. Say you have a data set like this, okay, wherein you have the details on whether a patient is tested positive or not with respect to COVID. You have the age of a person, okay, gender of a person, then historical health information, so on and so forth. And you have details on whether someone is tested positive or negative. In that way, you have the data. Okay. Here in this data, date and time and the sequence in which you arrange the data is unimportant. Okay, the date and time and the sequence in which you arrange the data is unimportant. If, for example, the reason why I'm saying this is because whether you go to hospital on a Monday morning at 8 a.m. before Rahu Kalam, okay, or after Rahu Kalam, whatever be it, it doesn't matter. If you are COVID positive, it will come out to be COVID positive. If you are COVID negative, it will come out to be COVID negative. Do you know what? If you go on a Tuesday after 12 p.m., you'll be tested negative. Otherwise, you'll be tested positive. There's nothing like that. So the date and time is immaterial, unimportant. Okay. And then the sequence in which you arrange the data, the sequence doesn't matter. Patient 1, patient 2, patient 3, doesn't matter. It can be in any sequence. If you're dealing with such a data where date and time and sequence are unimportant, it is called as cross-sectional data. And usually when it comes to cross-sectional data, you will have more than one variable. usually. Okay, now time series data. When it comes to time series data, say you want to uh, understand on how many COVID-19 cases would come tomorrow. How many COVID-19 positive cases would come tomorrow? Okay, and you have all the COVID-19 cases here. Number of COVID-19 cases. We have, I think, roughly 22 million now, but then say 22nd Jan, 23rd Jan, 24th Jan, so on and so forth. For all the days, you have the data, number of COVID-19 cases, and you want to now forecast the number of COVID-19 cases for tomorrow. If you want to forecast the number of COVID-19 cases tomorrow, just as an example, then you need to have the data arranged in that sequence. 22nd Jan, 23rd Jan, 24th Jan, 25th Jan. You need the data in that sequence. So here in this scenario, date and time and the sequence in which you arrange the data is important. If date and time and the sequence is important, then it is called as time series data. And there is also another data set called as longitudinal or panel data. And here usually what happens is you'll have a single variable, right? You'll usually have a single variable. And then you have longitudinal data or panel data. In longitudinal or panel data, you are going to plot number of COVID-19 cases in India, in USA, in Italy, in Brazil, so on and so forth. The point here which you need to note is that you will have features of both cross-sectional and time series data in this longitudinal data. You have more than one variable, so it has a component of cross-sectional data, and the number of COVID-19 cases, you arrange them in a sequence. So you'll have 22nd Jan, 23rd Jan, so on and so forth. When you have the data arranged based on the time sequence, then you're bringing in the time series aspects. On one side, you're bringing in multiple variables, that's cross-sectional. On another side, you're arranging the data based on date and time, so it's time series. When you have combination of these two, then it is called as longitudinal data or panel data. Trust me, friends, when I say practical, it is practical. Once you understand the data types and the data collection techniques, only then you would appreciate the algorithms that we're going to learn. We will learn about artificial neural network, right? We are going to learn about convolution neural network, recurrent neural network, how to deal with videos, images. Practically, we will do it using Python. But what are to be installed, what softwares you need, I am going to speak about those at a later point. Right? Maybe tomorrow also we would be discussing about theory, and from day after onwards we will get into practicals once we set a foundation very strong. So here we also need to discuss about another thing, which is balanced versus imbalanced data sets. And imbalanced data sets are also called as rare events. Imbalanced data sets are also called as rare events. So let's understand about balanced versus imbalanced data sets. For this, one thing that I need to explain is about the most important equation, which is y is equal to f of x. Y is output that you want to achieve. And the output that you want to achieve might depend on a single input, or the output that you want to achieve might depend on multiple inputs. For example, if you want to predict on what is the weight that I'm going to gain, then it depends on what? Number of calories that you consume. Okay, number of calories that you consume. That is going to determine the weight gain. Okay, next. Sometimes there might be multiple inputs also. For example, you might ask me this that, hey, what will be the salary after this training? What does it depend on? It depends on multiple things such as, are you attending all the classes? So it will depend on attendance for sure. Are you watching the video once again? Because at one go, people might not understand. They might want to watch. So I would say number of times you watch the video, number of times video is watched, plus it depends on your educational qualification, number of certificates that you attained. And trust me, you will have to work on live projects, at least one live project. And people who attend all the sessions, we will give you an opportunity to work on the live projects. Okay, and that will give you the practical experience that is needed. And once you have the practical experience, you can rule the world when you train your students. Absolutely right. Okay, so here an output might depend on a single input, or an output might depend on multiple inputs also. That aside, now balanced versus imbalanced data set. Let me take an example of, all right, COVID-19. No, let me take COVID. I already explained. So let me take the loan defaulters example. Loan defaulters. Age of a person, gender of a person, income, education, all those are given. Age, income, educational qualification, so on and so forth. All these are called as your inputs. And you have an output here, which is loan defaulters. Whether a person will default or not default. Not default. You have the data. Say you have data of 10,000 customers. To check whether your data are balanced or imbalanced, you just need to look at your output variable. Suppose you have 50% default. 50% of these say default, that means 5,000. And another 50% says not default. Then this is called as balanced data set. Okay, it's called as balanced data set. If you have, say, 40% default and 60% not default, still it is called as balanced. 30% and 70%, still it is called as balanced. If one of these classes means default or not default, one of these classes is less than 30%, which is 29%, 71%, one of these, it could be not default or default, then it enters into a zone wherein you can say that this is an imbalanced data set. This is a thumb rule. Take it with a pinch of salt. A lot of data scientists and AI experts, based on their experience, have given this thumb rule saying that If one of the classes is less than 30%, then that means it is imbalanced. This is just a thumb rule. Take it with a pinch of salt. Okay. And we have one more thing, which is batch processing versus real-time processing. But I think we might not have the time to complete this. So what I shall now do is I will quickly explain about a few things which are needed for you to understand. Number one, we will give you access to the videos, all the 10 days of videos will be posted on our private YouTube channel. Okay. And if you want access to this, all you need to do is you go here and oh, what happened? Sorry. Would it be there? Yeah. No, it's the link to attendance. So let me see once on where we have this YouTube channel. Okay, fine. It would come up any which ways here. Yeah, here it is. Here is a link. You please access this link without failure. I put the link in the chat window. All right, so I would also click here and okay, I'm not sure why that view is not appearing for me to post in the chat, but our team will do that. People who are logged in through YouTube channel, you anyways have access to this. Please, without failure, click on two things: subscribe and this notification. All the videos, the moment they get uploaded, you will be given access to that. You'll automatically be notified. Please do that. These are private YouTube channels. Okay, not the public ones. I mean, everyone will not have access to this. That is what I meant. So that's number one. Number two is we have posted the attendance link, okay, on our uh, screen. I'm also going to show you that here on the sticky note. You'll find that, and I'm going to post it here. There we go. Sure. We shall also, that's a very good advice. We shall also do that. But okay, once this, okay. In order to get a certificate, because AI and deep learning is the most in demand out of all the data courses, it's more in demand than data science, right? So you'll be given a certificate. If you get this certificate, you'll get only when you attend. If you get this, you will be entitled to work on live projects. Okay, one live project per person. We will give you an opportunity. So please ensure that you attend all the classes. Third thing is we will be sharing, we'll be adding you all to the WhatsApp. We will do it from our side. Okay, we thought we will share a link, but then we will do it from our side. We are going to add you all to the WhatsApp group because we have your details. And just wait until tomorrow. If you are still not added to the WhatsApp group by tomorrow, we will guide you on how to add yourself. Fourth, very important, we are going to post the quizzes on LinkedIn, where I'm assuming you all are active, because social media analytics is a very big thing. So I request you all to be very active on social media. On LinkedIn and Facebook, we are going to post the quizzes. You can respond to those quizzes, and tomorrow, I mean, this is not mandatory, but it is good because you might want to ask your students also these kind of questions, right, in the classroom, to engage them. So that will serve that purpose also. Okay, very important. Please take the quizzes also. And how to get to know what are the quizzes, where are those, right? So just go to 360digitmg.com. When you go to 360digitmg.com, you just scroll down and you'll find two links. One is the LinkedIn link for our page. On this page, you will see the quiz. Okay, you'll observe the quiz being posted here. So please make best use of that. And if you're not having an account, I sincerely request you all to create, because in big universities and colleges, they are looking at these things also on, because in data science or AI, social media and web analytics is a very big subject. And if you were to teach that subject, you first of all need to have an account. Okay. And please, there'll be an option to follow us. Please follow. Yeah, it'll be like this. Let me remove this admin part and show you, because I'm an admin, it's appearing like that. But for y'all, you'll have an option to actually follow. You can follow. Okay. Next, let me actually give you this link. Okay, tomorrow also we will post on our we'll be posting on the other details also, other sections. And then we have Facebook. If you click on Facebook here on 360 Digit MG, when you scroll down, when you click on this, you'll also get the Facebook link. You just need to click on that, and here you have an option to follow. I'm already following, so you're not able to see that, but you see here follow. Click on that, and here there'll be another quiz question which will be posted. Okay, and you might want to answer those quiz questions also. And thank you all so much. Tomorrow we are going to take this discussion forward. Yeah, you can Chandrasekhar, do this live project. AI is industry agnostic. Someone is saying that you are from arts. Do you know what? AI is used to generate images. And a first AI image which was sold, AI generated image sold. Where is that? Yeah. An artwork created by AI was sold for 40,000 pounds. 40,000 pounds. And you know what? Saudi prince was cheated by buying a photo portrait, right? This guy was fraud because buying photo generated fake. It was a fake photo basically, right? An image, fake uh, photo was purchased by Saudi prince. Okay, so yeah, here it is. Painting bought by Saudi crown prince for $450 million was found to be a fake. And fake photos are generated using artificial intelligence. Fake photos also can be generated actually. Okay, so that's what the industry or AI is doing. That's the flip side of AI. Okay, with this, we are going to stop the session, and please fill the attendance because you'll see a lot of benefits. You can actually, you know, watch the recorded video also on the YouTube channel. Please go ahead with that. There are 380 views. Subscribe and click on notify without fail. Thank you all so much for joining in. Tomorrow we will connect at the same time and we'll take it further. We'll post it on Praveen. We will post the link on WhatsApp also. Yeah, we'll post on the WhatsApp also. Thank you all so much, friends. Take care and stay safe. Tomorrow we will connect and take this discussion further. Thank you all.
session, and this is one of the series of webinars that we are conducting as part of our program, wherein we help people across various domains to learn something more about data science. So before I proceed, I'd like to just take a quick poll, and the question is, may I request all of you to please respond to this poll? Oh, perfect, 100%. I don't know if that is all the people. Quick confirmation. Okay, 80%, 83, 85. Perfect. So I guess as far as the visibility is concerned, that is not a problem. I'm sorry, as far as the audio is concerned, that is not a problem. I will now share my screen, and I will then ask you if you can see the screen. So in the same poll, once again, are you able to see window within window within window? Yeah, I'm assuming it is visible. So let us start. Welcome once again to 360 DGTMG. My name is Nitin Mishra. I'm one of the senior resources with 360 DGTMG. I have been with this company for over 5 years now. And because we are short on time, I will not bore you with my introductions, but I'm a mechanical engineer by qualification. I have about 23 years of total work experience, of which the last 5 years are in the space of analytics. I am an alumnus of Indian Institute of Management, Lucknow, a premium institute in the country, in India. I have done my data science program from there. And let us start. So before we start, I would just briefly like to put in a few words about one of the programs that we have launched, which is called Domain Analytics. This is especially something that we would want to give a lot of publicity, given that many of the people would want to do analytics but are quite ingrained into their current domain, that they wouldn't really want to change their domain, but at the same time want to use the benefit of analytics. So we have domain analytics, and we already have, apart from what you're seeing on the screen, we've already introduced manufacturing analytics, and we are going to come up with a total of 50 such domain analytics progressively we're going to introduce. So that is one advantage you may want to check out. About us, 360 DGTMG, we are having a bunch of accreditations. We are accredited with City and Guilds UK for the delivery of certifications. Of course, after clearing an examination, we have an tie-up with University Technology Malaysia School of Professional Continuing Education, and we also offer certification through them, a joint certification from 360 DGTMG and UTM. We also, our course curriculum is accredited with TUV-SUD, a leading certification body in the country. And just to give you a glimpse of what kind of certificates you would get, this is exactly what is there. And many of our participants have already started acquiring these kind of certificates. All right. So without further ado, let us now start the topic. We are discussing about linear regression model validation. Even before I continue, I would like to go back here and conduct another quick poll. Uh, just give me a moment while I type out the question. Yep. All right. So may I please request all of you to quickly respond to this poll? I'll give it another 30 seconds. I'm especially interested in the number of people who are have not done this, so that's the reason why this poll is of even more importance. Fine, I think we've got the numbers. So the majority of the audience, pretty good majority of the audience, about 78% of the audience, has already learned about regression, and therefore they are going to learn something new. So that sets the context with reference to the depth with which we can address this particular quick webinar. So linear regression model validation techniques is the name. So the original agenda was to introduce you to simple linear regression and multiple linear regression. I will spend as little time as possible on the introduction of these two. And then we'll move on to the model validation, where predominantly there are two things that we evaluate. One is the measure of errors, and the other is the measure of goodness of fit. So these are the two things that we are going to be doing. And given that 78% of the people have learned regression, I'm assuming you must be comfortable with the R as well, and therefore I'll be using R to explain that. So it makes things very easy. Perfect. So quickly, moving on, because most of you are aware about it. So we do regression. I will use this blank space to explain about it, because I'm a person, I'm a traditional kind of a teacher. I prefer the blackboard or the whiteboard and things like that. So I'll use this. This is for the remaining 22% of the people who are not yet learned about it, who will eventually learn. So if I have two variables x and y, which are having some kind of a linear relationship, the objective of regression is to find a straight line going through that. This straight line, all of you must remember, is the equation of the line y is equal to mx plus c, excuse me, wherein the m is the slope and y-intercept is equal to c, which is what is the value that this will take if the x value is 0. So in this particular equation, if I were to give the value 0, y would take the value c, and this is what we have here, which is y-intercept. This is the fundamentals. Once again, I'm sure all of you are aware. You may have scenarios where it is not just one, but maybe two variables. Let me try and do it a little better job. So I have one variable x1, I have one variable x2, and I have the output. Now, because we can only plot in maximum cognition that the human brain has is for 3-dimension, we really cannot plot this in a multi-dimensional space. So I'm going to stick to that. So every single data point here is going to be defined by three variables, x1, x2, y. Right? This particular point is also x1, x2, y. So now when I have such data points on this particular space, we no longer have what is called as the line. The model will now become some sort of a plane. All right, some sort of a plane. The data points will be pretty close. So you may want to imagine a plane which is having 2 dimension, and you may have certain data points sticking to the plane. You may have certain data points above the plane. So whatever I'm drawing in blue are data points that are slightly above the plane, and you may have certain data points which are below the plane. So what you see in green is below that. So try to understand this in a 3D perspective. If I were to plot it even better, I have one dimension. This is only one dimension of the plane. All right. On this plane, I have certain data points. Above the plane, I have certain. Below the plane, I have certain. And this is the model that I have. Now, what defines a plane when you're talking about 3 dimension is y as a function of some constant plus a variable a with x1 plus a variable b with x2. This is essentially what it is. Now we can extend the same logic for more than 2 inputs. When we have more than 2 inputs, we can extend the same logic with y is equal to a constant c plus ax1 plus bx2 plus cx3 plus, sorry, c is already done, my bad, dx3 plus ex4, so on and so forth. Excuse me. Now, this particular form of the equation is simply referred to as y is equal to f of x, wherein we try to find a relationship between all the inputs simply represented by x with reference to the output y. Now, once we build a model, the most convenient and the most easy way to understand about model building is in a 2-dimensional space, that is a single input x. So when I have my data scattered like this, and when I build a model going through this is the model that I built. Just quickly to tell you, this is all a recap. So people who are not able to understand this might want to visit our channel and look for linear regression. So linear regression we will be having. You can in our channel, the 360 DMG channel, we have another video called linear regression. You may want to check out that and probably visit this. Okay, so this particular equation, which is a straight line, is y is equal to, now in regression, when we talk about regression, all right, regression is predicting numerical values. We say regression is predicting numerical values. So in regression, y is given as, the equation y is given as beta naught plus beta 1x, where the beta naught is your c and your beta 1 is your m, essentially the same thing. The output of any model, how do you do a model? You have a tabulation of data, you have the inputs and you have the outputs. You have the value of x, value of y, value of x, value of y. For this value of x, value of y, we want to have the equation. So the equation will be y is equal to beta naught plus beta 1x. And if it is x1, x2, so on and so forth, it will be x1 plus beta 2, x2. Let me write it in the next line, beta 2, x2. So this extends. So we are quickly understood that simple linear regression is only when there is a singular x. Multiple linear regression is when you have multiple x's or inputs. Now, let us now understand about the model evaluation. Before model evaluation, we have two basic things. One is the error measures and the other is goodness of fit. So let us first talk about goodness of fit, then we'll go back to the error, because within the goodness of fit, the error measure also is something that is explained. So we have a measure for linear regression, whether it is simple linear or multiple linear. We have a measure which is called R squared. All right. This R squared, we have a formula We'll not dwell too much onto it because I believe some of you, I mean, most of you are already aware. And if you are not aware, you can always visit our channel and look for linear regression. It will be explained there. All right. So we have a measure called R square. Now, what does R square measure? It measures essentially two things. One is what is called the SSR and other is SSE. In simple terms, the SSE is a measure of error and the SSR is the measure of goodness, or how much it is able to explain. A combination of these two measures is also a measure of goodness. The simple logic in very layman terms, what R square measures is not just how well the correlation between the data points are, but also how well the input is able to explain the output. To understand this, let me give you an analogy. I will use this blank space here. I have one scenario where I have data points between X and Y very close to each other. And I have another scenario where I have data points between X and Y very close to each other. At the first instance, the closeness or the correlation between X and Y in both scenario 1 and 2 looks the same. But the ability of model 1 to explain about the Y is much better because of this measure of slope. So if the correlation is poor, it can be compensated by a very good slope between the X and Y, and this model can still be good. If, on the other hand, you have a very poor slope, but if the correlation is pretty tight, then this model is also compensating for the lack of its ability to explain the Y with its ability to have a very less error. So we've understood a very simple thing about what is called as R square. Let me just dwell a little more on that by showing you two examples. I have here model 1 and I have here model 2. And this here is the data that I am showing. And this here is the data that I am showing. We have one X and we have a Y. We have the X, sorry, my bad, and Y. Now, for this and this. So if you look at it carefully, let me also draw it. The error measures, which is the sum total of the red vertical lines, is so much, and the error measures for this, the sum total of the red vertical lines, is so much. Now, if you look at only the error, model 1 seems to have definitely more error compared to model 2 because the sum total of the red lines of model 1 is more compared to the sum total of the red lines of model 2. However, the slope of this particular model 1 is definitely higher, and therefore when you have the equation, your equation of the line will be beta naught plus beta 1x. This beta 1 value here is going to be high. Therefore, any change in x is magnified by so much of beta 1, which is having an effect on the output y. Whereas here, your y is equal to beta naught plus beta 1x. This beta 1 value is low. So whatever change in x we have, Let us assume for the sake of understanding, this beta 1 value is 3.6 and this beta 1 value is 0.031. Now, if I were to increase the x value from 1, 2, 3, 4, 5, let me just erase this and make it a little better. If I were to increase the x value from 1 to 2, the net effect on the output y is by 0.031, which is very minuscule. So what is the effect that x has on y is less, and what is the effect that x has on y here is more. But because the errors are less, this model is equally good as model 1. It may be equally good. So that is why we have both the measures, which is sum of squares of explained variation, which is the numerator SSR, divided by SSR plus SSE, where SSE component is the error component. So we've understood about one measure, which is goodness of fit. This slide, of course, is not relevant at this point of time, but nevertheless, we always have to look at something what is called as confidence interval and prediction interval, because we can never really give a prediction with reference to a single value. Let me just talk about that. This is again like a recap. If I have data, some x and some y, and if I were to plot this, the whole objective of modeling is to be able to predict for a value of unknown x, for a value of known x, to find the unknown y. Now, my x and y data, which I have a tabulation, I have a lot of values. And based on these values, there is a value that I want for this, for which I want the output. So I will plot this here and take the output. Now this particular value is what is called as the predicted y. This again, most of you are aware. But the predicted y is a predicted value, and therefore it is not accurate, and therefore we can never be sure. So what we do is we put an interval around the predicted y and say, for this value of, let us say, xa, my predicted value will be in this particular range. So that is the concept of interval, which is essential. We also have two things, prediction interval, confidence interval, that anyway we can learn from our different sessions. Now moving on, what are the assumptions with reference to model? This again I will quickly go through because I'll be spending time on the actual code part of it. So the expectation, what we expect our model to be, something like this. We are obviously talking of the multiple linear regression. We expect it to be linear in parameters, meaning these values beta naught, beta 1, beta 2 are entering this equation linearly, meaning these beta naught, beta 1, beta 2 values are essentially a constant and not a resultant of a function. They are not a resultant of a function, but they are a constant. So therefore, any change in beta 1 or beta 2 will result in a linear increment or a linear kind of a thing. It may be negative or it may be positive, but it cannot be a curve. This is not possible. So that is linear in parameters. We have methods of finding that out. All right. Assumptions about the errors is, again, we expect it to be identically and independently distributed normal, meaning most of you are already aware, we expect the errors to follow a normal distribution curve and each one of them to be independent of the next. We also expect it to have a zero mean. Why do we expect it to have a zero mean? If this is my model and these are the data points, and if these vertical lines is what I have, then the line that is going to fit through these data points, the red data points that you have seen, should be such that it averages out perfectly, which intuitively refers to the fact that this positive value and this negative value, this positive value, this negative value. So all the positives minus all the negatives should be equal to 0. That is what is the zero mean requirement. It should have constant variance. Now, once again, this is an aspect that I will not explain the y part of it, but if you were to plot the errors in a control chart, all right, and if you have the errors from beginning to end, you expect the errors to be following some kind of a standard kind of a pattern, rather than you have the errors following some kind of a irregular pattern. That is, it is quite distanced here, then it starts to fall down, then it becomes pretty close, then it becomes distance again, then it goes like this. Now similarly, so this is not acceptable. If you have such a scenario, it is called a heteroscedasticity. Like I said, we will not get into the why of it. This is how it should be. All right. And of course, independent of each other, otherwise it is autocorrelation, meaning which the error 1, error 2, error 3, error 4, error 5, they should not have any relation with each other. All right. So moving on. Assumptions about predictors, non-random, measured without error, which is pretty much obvious, and linearly independent of each other. So let me explain about linearly independent of each other with a quick illustration. Once again, many of you are aware, but still for the benefit of new participants. So if I have x1 and y, if I have x2 and y, having a good correlation between the input and output, whether it is positive or is it negative, is good. However, between the x1 and x2, if I have a good correlation, this is bad, this is good. That is what this particular statement here says, linearly independent of each other. Therefore, the last example that I had shown you here, if you have such a thing between the x1 and x2 or any combination of the inputs, we have a problem of collinearity at our hands. Now, moving on, there are, of course, the tests to find out. Assumptions about observations equally reliable. That is pretty much. So what is important? The important aspects are normal, zero mean, constant variance, and linearly independent of each other. These are the important things that we are going to be referring to. And I'm going to be using a standard data set. This is a data set available in R as well to explain about it. So there is the output here, and you have the inputs x1, x2, x3, and x4. And we will be loading this database and checking it out. So before I proceed any further, just some illustrations with reference to the homoscedasticity. I had drawn it, but it was not perfect. So this is good, this is bad, this is bad. All right. So that is with reference to homoscedasticity. How to fix such a problem? Same as you trying to fix something which is fix the problem of normality. When I say problem of normality, the absence of normality. So if I have data, let me just address that for a moment. If I have data and if I were to plot it and if I were to get some kind of something like this, a very, very long tail kind of a thing, obviously I cannot call this normal. So looking at this particular histogram, we can make out that we need to transform the data, and a log transformation or an exponential transformation will push the data, or this particular data will be expanded. It will be expanded on both sides. So you will have, once you do the log transformation, something like this. Obviously a long tail towards the end, but nevertheless it will make this transform. So when you are transforming the value to make it normal, the same issue of homoscedasticity can also be addressed by the same, that is, do some transformation, and therefore that will take care of the homoscedasticity. We will be discussing something about leverage, which will be an essential part. I'll be doing a lot more discussion about leverage. So let me now go to the regression. One moment, and it's just, yep. So once again, all of you are well versed with this. So let me open the regression model that I'm opening. So now that we are already aware about the simple linear regression, I will skip this. This is anyway, the code was already there, so I just put it there. So let us quickly load this particular file. And we are loading the cars file. We can have a view of this. So we have about 81 observations, 5 variables. These are the 81 observations. All right. And the 5 columns, one of them is the input. So that's that. We attach it because we don't want to keep referring the object name. Again, this is something that is already covered with reference to our, you might want to check out our channel with basics of R. All right, there are videos that will address all these things. And PDA is something that is an essential part of it. Students of data science are well aware of that. It is drilled into the heads of all students that EDA is something that is going to take up enormous amount of time, and this is what we have done. So by taking a good look at this, let me just quickly point out, all right, one moment please. Yeah, so let me just quickly point out, you can see here that the HP, which is horsepower, is having a very long right tail. All right, you're able to appreciate that it is very long right tail because the mean median is about 100, whereas the max value is 322. So if you were to plot this, it would look something like this. Now this may be required to be addressed as part of the normality. You may also want to look at the MPG, wherein it kind of looks symmetrical because it is 12 is the minimum value, 53 is the maximum value, and halfway point is 35 or 34. So both sides is kind of symmetrical. So this value looks to be something like this, which is your MPG. So that is not a problem. Now coming back to volume, once again, the midway point is 9800. The low point is 50, so 50 to 100 is 50, but 100 to 160 is, again, this is pretty much the same. So there might be a slight longish tail, slightly longish tail, but this is also acceptable. All right. All these things as part of EDA you must have already learned. Now, excuse me, one moment please. Yeah. Now when we look at this particular scenario here, the SP, we have starting from 100 to 169, 170, just 70. So 100 to 70, 100 to 170, my bad. The halfway mark is 135, but we are reaching the halfway mark at only 120. So once again, the halfway mark is here. So we are having a long tail to the right. So almost all the columns except for probably MPG, we have a long tail. Now let us look at the weight, 15 to 53. All right, 15 to 53, let us round it off 15 and let us make it 10 to 50. The distance is 40, so halfway mark should be 20. Now this is interesting. This alone is having something like this. So it is kind of left-tailed. So these are some of the insights that is expected of a data scientist, a seasoned data scientist, to be able to do it in a jiffy. You look at this, you spend not more than 15 seconds and you draw the conclusion. So 15 plus 15 plus 15, you should be able to figure out in about minute and a half. If you have these spelling, just about minute and a half, you should be able to figure out what the data is telling you. So that is an essential aspect. Now, because the topic at hand is something else, I will not be dwelling too much on that. So let us quickly run through the code. So when we look at the plot, which is the correlation between the input and the output, it is a pretty decent correlation. We can continue with this step by step, or we can simply go ahead and do what is called as the pair cars, and pardon me, do the pair cars, and we get all the plots in one go. What we are trying to look for is MPG versus HP. Let me use a different color. So MPG, excuse me, MPG versus HP, volume versus MPG, MPG versus SP, and MPG versus weight. So we are looking at these three and this one, the relationship. The same thing is shown on the upper side, but as the axis has changed, so we will ignore that. So good, not so good, but okay. We will go ahead and proceed. But what is glaring is with reference to this particular correlation, which is between the inputs HP and SP and the inputs volume and weight. Now we've already learned that we are having a collinearity problem at hand. Now how do we address this collinearity problem is the essence of what we are going to be doing. So I'll quickly run through the model, because model part of it, all of you are clear. So you may want to look at the correlation of all the values, and you can see here that while the correlation between the input and output, excuse me, while the correlation between the input and output, HP versus MPG is good, volume versus MPG not so great, but okay, SP is fine, weight is not so great, but yeah, there is a correlation. But the biggest concern is these two values between the volume and weight and HP and SP. All right, this is the biggest concern that we have, and let us now go ahead. So what are we going to do? We are going to build a model. The method of building a model is LM, MPG, volume, HP, SP, weight. These are the inputs. So we are building a model with MPG as the output and the remaining as the input. When you look at the summary, which is the outcome or the model, now how does the model look like? If you are, the model is y is equal to beta naught plus beta 1 x1 plus beta 2 x2 plus beta 3 x3 plus beta 4 x4. This is what we have. So x1 is your HP, x2 is your volume, HP, SP, and weight. These are the values. So if you have this equation, we have the output, which is MPG. So 30.6 plus negative 0.33 into volume minus 0.205 into HP plus 0.395 into SP plus 0.400 into weight. So this is how the equation would be, but even before we jump into the equation, we have issues with reference to the significance. So we find that this volume measure is not a significant measure, and similarly we find this weight measure is not significant because the p-value, we expect the p-value to be less than alpha, and I'm sure all of you will remember alpha is equal to, if in case it is not mentioned, alpha is equal to 0.05, but we have here these values 55%. 81%, which is pretty high. We have to bring it to, if not alpha is equal to 0.5, at least we may expect it to be alpha is equal to 0.1. Maybe in that aspect, maybe we can make a concession, but 55%, 81% is definitely not acceptable. So what do we do about it? Prima facie, it appears that we have a problem with reference to this particular extreme correlation, and that is what is causing this. So let us address that part of it. All right. So we are going in for some kind of diagnostics to figure out what is the problem. All right. So I'm going to load this package called car, and I'm going to do the plot. Now this plot model.car. Now some of you may not have had a chance to look at this, but I'm going to explain that. So when I look at this, there are some 4 plots that tell me. So I will place my cursor here and press it. I get a plot. So this plot tells me about the fitted values, which is the y hat, and the residuals. Now I expect most of the values to be on both sides in such a way that this red line should have been on this particular line, which is pretty close. I find that maybe my red line is at least not like this. It is pretty close. It is up, it is down, it is up. It is pretty close to it. So this particular aspect, residuals versus fitteds, where I expect equal values on both sides, is getting satisfied. So this aspect is all right. So residuals versus fitted, if you want to refer back, we were talking about the linearity. So this is something that we have addressed, and this is being taken care of. Moving along. The next plot tells us about the normality of the errors. We've already seen about the IID normal. So the errors are normal. This is also a good sign. Next plot tells us about the standardized residual versus fitted. This is a measure of your homoscedasticity, which tells us about how we expect the values to be equal on both sides, except for maybe a little bit here. By and large, this line is kind of straight. Here it kind of moves off. So there could be some problem here, but by and large, we find that the homoscedasticity or constant variance also has been taken care of. The next plot, or the final plot on which we will be discussing a little bit, is called the leverage. Now this is where I'll be spending about a few minutes. The leverage is something that is telling us how good a model is, or how much improvement a model has had because of the absence of one data point. Now I know it's a little difficult to understand that, so I'll explain this with an illustration. I will use the blank space here to explain about leverage, or I think I already have already created a screen to explain about leverage. Yeah. So let me just use this blank space. So I have data on a 2-dimensional space, and excuse me. So I have these 5 data points. Now, if I were to build a model using these 5 data points, I would get a line something like this. Now this model we have already studied. Now it is not about this model that I'm interested in. I am interested in building 5 different models, and each time I'm going to ignore one data point. So the first time I ignore this data point. Now when I ignore this data point, I get a model which looks something like this. Now what is the errors because of this? We will record it somewhere. Next, I build another model This time I ignore this data point. Now, when I ignore this data point, the model that I get is something like this. Now, what is the error I'm getting in my model? Remember, the circled value is not there. How much error I'm getting is what I'm measuring here. I record that. Subsequently, I build another model. This time I ignore this data point and my model appears like this. I mean, it is to go beyond that. I'm not able to show it now, but you get the general idea. So like that, I continue and finally ignore this, and the model that I get is something like this, which is a pretty absurd model, right? We really don't get a good model in this. And finally, what I do is I ignore this data point. Now, when I ignore this data point, the model that I get is this one. Now, I think it is evident visually that the purple model, by virtue of removing this particular data point, is the best among all, or the improvement in the accuracy of the model is maximum when I get rid of this purple data point. So what your leverage tells you is, for every single data point, what is the quantum of improvement? For the removal of the 77th data point, the improvement is so much that it goes beyond a measure called the Cook's distance measure of 0.5, that it is so much. So this particular 77th record in a multidimensional space can be treated as an outlier. Some extreme value, and as we understand about outlier already, outliers are those values that enormously push up the mean value or push down the mean value. On similar lines, a record is an outlier which can absurdly or negatively impact the model's quality with reference to accuracy and goodness. So we may want to, in real life, when we are building models, we may want to look into the leverage, identify these kind of data points. Even this is pretty close to 0.5, all right, maybe 71, after 77, maybe 71, then maybe 79. In that order, we may want to address it one by one, remove it. And modeling is definitely a trial and error procedure. So does the removal of 77 improve my model's accuracy? Does the removal of 71 improve my model accuracy? Does the removal of 79 improve my model accuracy? By how much does it improve? We also have to take into consideration things like, whether this particular thing is really worthwhile. I have only 50 records, and the training that 360 Digital told me that we should remove anything which is having a high leverage. Then 15 records are getting removed. Then what are we left with? So it is a subjective kind of an issue. If you have very few data points, you cannot afford to, go away with 15. You may want to do that. If you have, let us say, 5,000 records and only 3 records are there, don't even think about it. Just get rid of those 3 records. So this is something that over a period of time, with reference to experience and the kind of domain you work with, you may want to take a call on that. So that was with reference to the leverage plot, which I thought I'll spend a little bit of time, but that doesn't really solve the problem of my input variable, my model coefficients being not significant. They are not significant because their probabilities are high. So what do? I find out which of this is causing a problem. So we have something called as the VIF, which is the variance inflation factor. The variance inflation factor measures indirectly how much correlation exists. So here I'm bringing in the concept of what is called as multi-collinearity. We have discussed about collinearity when these two values, so this x and y, are having a good collinearity, or when we have x1 and x2, they have a very good collinearity. But how do you measure x1 versus x2, x3, x4, all the way to xk? This is one measure of multicollinearity. x2 versus x1, x3, x4, so on and so forth. So the VIF measure tells how the remaining people are opposing, or rather than opposing, how these remaining inputs or remaining variables are having a very good correlation or a poor correlation with reference to the variable in question. So this VIF gives you a measure called variance inflation factor, and as a thumb rule we expect it to be 10 or less. If it is more than 10, then there exists a multicollinearity. So we find that when we are taking volume versus weight, HP and SP, these three together, their multicollinearity with volume is 638, which is a very high number. Similarly, when we put weight here and we put volume here, volume, HP and SP with weight have a multicollinearity of 639, which is again a very high number. All right. So these are the things that enable us to decide which particular variable needs to be removed so as to make the model good. Now next, we have another measure called the AV plot. I will take a minute to explain about the AV plot concept, all right, with reference to a blank space. So let me use this same space here. We are talking about the AV plot. So let us assume we have a model we are building with x1 and x2. And x1 and x2 have very good correlation. The correlation between x1 and x2 is very good. So what is going to happen when I build a model x1, y1, let us say the correlation is -1, let us for sake of assumption. So what is going to happen every time this particular y here is y is equal to beta naught plus beta 1 x1 plus beta 2 x2. All right, beta 1 x1 plus beta 2 x2. So I want to see in my equation, if I were to change the value of x1, what is the effect on y? By only changing the value of x1, what is the change on y? So when I change x1 from, let us say, whatever the value is here to the incremental value, some x delta x1 plus 1, x1 plus 2, x1 plus 3, I expect, depending on the correlation, my y value to increase. This is what I expect. But because of this correlation, what is going to happen? Whatever effect that x1 is trying to give is offset. So x1 is pushing it upwards and x2 is pushing it downwards. When I do it again, another value, it's pushing it back. When I do it again, pushing it back. When I do it again, pushing it back. So the net resultant or the displacement is kind of a straight line. What does it mean? It means that x1 has having no contribution to the output y because of the opposition of x2. Now extend this opposition value of x2 as opposition of all the other input values. Now if you come back to the AV plot, there is some opposition. What is the contribution of SP with MPG? So SP alone would try to go so much, but the other three are pushing it back so much. So there is still some slope. MPG versus HP. So HP alone might want to go like this, but the other three are pushing it back. So there is still a slope. But when you look at the weight, 3 steps forward that the weight takes, the SP, HP and volume push it back 3 steps. 3 steps forward, 3 steps back, 3 steps forward, 3 steps back. Therefore, the weight as an input is not able to contribute in the success of the output MPG, and therefore this should be removed. Volume, on the other hand, still has some small slope starting from a value above 0 to below 0. It is still having some value. It is going back and forth, but weight is obviously not having anything. So given this, we have decided that we will get rid of weight. So we build a model with only volume, HP and SP. We look at the summary. Now when you look at the summary, the problem of significance gets solved. All of them are below 0.05, which is a good thing. And to look at some more of the metrics with reference to the quality metrics, AV plot and VIF plot as a quality metric, when you look at that, we see that volume, which was having an opposition from weight, is also able to contribute. When we look at the VIF value, we had a 639 value for volume, a 638 value for volume, and 639 value for weight. In the absence of weight, now volume is also able to contribute more to the model. So therefore, not always are the inputs good. Sometimes trying to accommodate all the inputs may be counterproductive. It is important to, sometimes let go of these things. So that concludes our discussion with reference to this particular topic at hand. I do hope you had an enjoyable time. Let me see what are the questions. I'm sorry, because when I'm there, I could not. So N is the number of points, number of important or critical points. So you remember where we had seen, 77, 71s and 70. I don't know what was the number. Let me just go back and then, I closed it. There were only 3 points that were marked out. So that was what is. So that is one thing. And screen is blurred. Was everybody facing the screen blur issue? Okay, even if one person is not facing that issue, then it is not at my end. Thank you. So just a quick, just before you leave, a quick poll once again. All right. Let me just do it. So please wait. Just a minute. Yes. Can I please request you to select your answers? I really don't know how many have responded, so I really cannot comment that it is a good score or not. So please do mention in the feedback column with reference to what topics would you like to be explained at a later point of time. Feedback from participants is definitely an important aspect. In our comments column, you may request you to please comment on the YouTube channel and also, tell us what all the things that you expect us to tell you about it. So, yeah, thank you so much. Have a great day, and please stay tuned for more such programs. Thank you for your feedback.